Hello, everyone. My name is Manuel, and I am speaking to you from Madrid, Spain. I am going to present for 4 winning solutions for the competition. I am delighted to be here with you. I would like to greet staff, to greet Kaggle staff, and to greet and congratulate the other Kaggle competitors who are here to present their winning solution. Half page, Elizabeth, to Elizabeth.
Yes.
Go to page background, next.
Okay.
I'm going to start the presentation by telling you a little about myself. I have a degree in economics. I finished my postgraduate studies by taking doctorate courses in the Department of Applied Quantitative Economics, thereby acquiring research proficiency. I am passionate about econometrics, and it is this knowledge that led me to approach the world of machine learning with relative proximity. I can say that while I am satisfied with everything related to my academic curriculum and the field of teaching, the same is not true of my professional experience in the world of business and corporation. I believe, as you can read in the presentation, that I still have something to achieve here. I didn't know anything about MCTS algorithms, so I approached these competitions without that background, but in Kaggle competitions, this is usually more than less common. I didn't join the competition from the beginning. I did so 1 month later, and my dedication was more intense as my position on the public leaderboard went up. Go to code sharing. Thanks, Elizabeth, and sorry for all of them.
No problem.
Okay, code sharing.
Yes.
I am now more fun to tell you about what I shared on Kaggle platform once the competition was over. I created a Kaggle topic doing a quick write-up of the development of the competition. I made public the inference code that got me 4th place on the private leaderboard. I also made public all notebooks and datasets that take part as inputs in this final solution, so that is reproducible by the This notebook is hard to follow, so publish a better referenced notebook based on the original to make it more user-friendly. Go to Kaggle Learning.
Okay.
One moment, please. Okay, best. Kaggle Learning, this is a special section for me because if any of you know my solution, you will agree with me that the result I achieved wouldn't have been possible without the help of the community. I mean, those Kagglers who share their solutions or their discoveries during the development of the competition. It's not that my solution was better with their help, but that it directly influenced how I finally approached this competition. There was a great number, level, and diversity in the shared notebooks. My sincere thanks to all of them once again, and particularly to the users you can see here on the presentation table. Go to log notebook.
Okay.
Perhaps the name of this slide doesn't really fit what a log notebook, would be, since it doesn't go into greater detail and simply explaining how the emotional development has been on my side in this competition, and how this contributed to following an approach that finally ended well. Allow me now to put aside my notes and read directly the content of the slide, as I believe it faithfully summarizes what I want to convey you. I then stop for a few seconds. Go to summarizes the solution in a generic way. I must tell you that my contribution has basically been the construction of a final ensemble that includes 11 machine learning pipelines. There are 3 more objects that are included in the final merge function, but they are derived from very simple chains on the original notebook. As you can imagine, what has worked to both individual performance improve of the whole has been the diversity of models and features. Gradient boosting algorithms have dominated the modeling methodology in this competition. The solution, CatBoss, has been the most used model, followed by light DBM. There is only one pipeline close to neural nets that was used from the deep tables toolkit. Halfway between the traditional LP and the gradient boosting themselves. Individually, it worked well on the score, but surprisingly, it didn't shoot up the performance when mixed with other models, as usually happens. Perhaps because if I am not mistaken, this tabular net extract features from 3 methods internally. Regarding feature engineering, we mainly deal with the treatment of text type variables. Basically, those referring to agent and rules features. Here include everything from a simple D-type to categorical for the automatic treatment of the models. Transformations, one hot type, PFIDF vectorizer, and then a soft transformer trained for embedding. The interaction of characteristics is almost absent, and we will find the generation of new numerical variables beyond simple simple ratio. As for the validation strategy, has predominate the use of 5 group k-fold with the variable game rule set names as group. There is some experiment that stratifies the target as binary. This is a stratified group k-fold.
Sorry, were you on
Go to second page, next page, second page after solution overview.
Okay.
Well, I continue the general description of the solution by referring to how the outputs of all the pipelines are merged. We will see this more clearly at the end of the presentation. So you can read it again here, directly from the slide. I stopped then for a few seconds.
Are we on the same correct slide, Manuel?
Okay, you read the slide and pass to feature engineering.
Okay, now we're on features engineering.
Well, while returning to the feature engineering process and variable selection, I will include some more details here. For example, then okay. For example, the number. One moment. Well, I continue. And variable selection, I will include some more details here. For example, the number of features that are used in the final training. There is also a weight variety here, ranging from a minimum of 54 variables to a maximum of 39. Some of the notebooks worked in this sense from a previous analysis of variable selection based on the feature importance extracted from the training of GVDT models, and even some in a more sophisticated way analyzing the correlation. In general, a high number of variables are usually repeated and dropped from the original dataset. These normally correspond to the usual data cleaning and purifying process, although there are also some more sophisticated elimination process, such as correlation analysis. Although they are not very abundant, feature engineering related to numerical variables is normally related to features that have to do with time, duration, or complexity. As we said a few slides ago, most of the action here refer to processing text column. In the next slide, we can see a miscellany of what the performance of the new features was based on the rank they obtained in the analysis of the feature importance. We can see how most of this process focuses on agent characteristics with an excellent result. Matryoshka pipeline use a transformer model for embedding we now saw good results, partly because the model was not trained in depth. Jun Susiaozi pipeline and long GGGL work with an inverse frequency matrix for obtaining better results. In terms of numerical variables, there is an interesting example in the Yuki's pipeline, Yuki Zeta, Yuki X pipeline, that includes a two-state modeling, where in the second stage it includes as features the youth records, and we can check how they rank in 4th and 5th place successfully. Go to machine learning pipelines.
Okay.
We are coming the end, and what I present here is a table that very succinctly summarizes some details of each of the 4 theme notebooks that the final ensemble includes. Here, featured columns show the number of features that make up the training. In parentheses is the number of new features that have been generated. We see that 2 and 3, both Yusun Xiaozi pipeline, stand out. Training column, show the methods or models that have been used, where you see that the majority are CatBoss and light GBM. Validation scenario, the ensemble, the method used by each of the notebooks. In the case that there is more than one model. The validation scores and public and private score too. There were some typos I showed this morning regarding your version in rows 2, 3, 5, and 6. If I remember correctly. I'm going to interesting. Well, to finish, I show you here a photo of cascade structure and weights of the final ensemble. 2 or 3 weeks after the start of my participation in the competition, and performing a linear optimization, a linear optimization exercise to find the best weights in an ensemble between CatBoss and LightGBM. I found that the best result for one of the algorithms had a negative weight. This fact, although possible, is not frequent, so it led me to try negative weights for those solutions that had been discarded in my ensemble, for now improving the public leaderboard. I always made sure that the sum of the weights was 1. Next. With a simple linear optimizer on the youth, you might also find that adding a multiplier to the prediction result improves performance. You can stop in that point or by using that multiplier via UF, or if you rely on public leaderboard as a whole, you you may want to optimize that multiplier by trial and error. The rest of the tricks a little impact. I mean, raising the prediction, depending on whether negative or positive, and the final clip to hundreds below minus or one and one. Minus 1 and 1. Well, go to one. And finish at the very last. I suppose this solution can serve as a RMSE reduction function of the strongest notebook shared by the community in this competition. I'm sorry for my English, and gracias, thanks a lot. I have activated the subtitles, and perhaps understand if any question.